Good morning, year 12. Let's start today from what we finished by last time. The last time we finished with a question about iron. Explain why iron 2 is easily oxidized to iron 3. As you know, this question, to start answer it, we have to first do the electronic configuration of iron. Electronic configuration of iron will be Fe argon 4s2 3d6. This is the normal iron. So, in this question he asked about why iron 2 easily oxidized to iron 3, and of course he means that the inverse is hard. But if he easily can change iron 2 to iron 3, this means iron 3 is more stable. So the question here is why easily we can change iron 2 to iron 3 and why iron 3 is more stable. By doing the electronic configuration of iron, which is Fe argon 18 4s2 3d6, this is a normal electronic configuration. Positive 2, which is iron 2, in this case the iron lose 2 electrons from the S and change to electronic configuration 4s0 3d6. But positive 3 losing 3 electrons, the 2 electrons of S and 1 electron from D, so the rest will be 4s0 3d5. This is positive 3. Now what is the difference between positive 2 and positive 3? It is the number of electrons in the D. As we studied last time, the more stable atom which contain orbital D that have 0, 5 or 10 electrons, because these three states empty, half full or full. Okay, in this case, which one of these two atoms will be more stable? Of course positive 3, because the D is half full with 5 electrons. So the answer of this question explain why this is more stable or easier to oxidize into this, because Fe positive 3, you will first write the 3 electronic configuration, then you will write after this, because in iron 3 the orbital D half full, and this means it has less energy and more stable. And more stable. So this what we said last time. If the d orbital contain 0, 5 or 10 electron, the atom will be less energy and more stable, and this is the key of the answer. Less energy and more stable. Okay, the same, the next question. Manganese positive 2, manganese positive 2 is not easily oxidized to manganese positive 3. Now first, the manganese is 25, the electronic configuration argon 18 4s2 3d5. In this case, he wants to make the manganese positive 2 and manganese positive 3. Let's do the electronic configuration of manganese positive 2 by removing 2 electrons of S, and manganese positive 3 by removing 2 electrons from S and 1 from D. Of course, in the manganese positive 2, as you see, which one of them will be more stable? Of course, the more stable is when the D orbital is 0, 5 or 10. So manganese positive 2, which contain D5, this is the more stable, and it is more stable because the orbital D half full, so it is less energy and more stable. So we will put the same sentence here. More stable. Why? Because it's half full. D is half full, less energy and more stable. So it is easy to change Mn positive 3 to Mn positive 2, but the inverse is hard. Okay. Now let's go back for the PowerPoint which we studied last time. And we will get to a very important question today. The question is about what is meant by transition elements. Transition elements. And to understand what is transition element, let's have the definition, then explain the definition. The definition of transition element: it is the element that incompletely filled the D or F sublevel in either atomic state or in one in its oxidation state. So this is a definition of transition element. Okay. As we see in this definition, he said that any transition element must have the D or F incomplete. We cannot have a transition element with a complete D orbital or F orbital. So we cannot have a transition element that have D10 or F14. In one of the two cases, in atomic state or the oxidation state, يعني a normal state or positive state. And we have a question about this to understand. Let's come here to the coinage metal. Give reason. The coinage metal: copper, silver and gold, it's group 1b, are considered a transition element. Why these three elements are transition elements? Coinage means they made the coin. The coins made of copper, silver or gold. Because of that they call these elements coinage metal. And if we'll take a look for the periodic table, you will find the coinage elements here in the same column: copper, silver and gold. They have the same electronic configuration, which is 4s1 3d10, 4s1 3d10. Going back to here, copper 3d9 4s0, when we have just one oxidation state for this element, which is positive 2, كلهم positive 2. In the normal case they all have d10. If this case is the only case for this element, it wouldn't be a transition element. But because they have positive 2 case, by losing one electron for S and one electron for D, change to be for S0 3d9. The D now is not complete, so they are transition elements. Of course, the same happened with gold and silver. So the coinage metals are transition element because in the positive 2 state, oxidation state positive 2 for each element, the D will contain 9 electron, not 10. So it is incomplete and the element is transition element. Okay. The next question is zinc, cadmium and mercury are not transition elements. Okay, let's take a look first for the periodic table. Zinc, cadmium and mercury. They are the three elements or the three last elements in each period. The electronic configuration of the normal atom of these elements is 4s2 3d10, 4s2 3d10 or s2d10, s2d10. The oxidation state of this element positive 1 and positive 2. Even if we said positive 1 or positive 2, the atom will lose the electrons of the S and will never lose the electron of D. Because of that, it will be always having 10 electron in the D orbital, even in its state positive 2. losing 2 electrons of S but still having 10 electrons of D. And as we said about transition element, they must have the d orbital incomplete. But this case, Zn and cadmium and mercury, the three in normal state and the oxidation state, they have the d complete. Because of that, they are not transition element. And taking out the 3 elements from transition element, they turn to be 27 elements, not 30 elements. 3 elements out of 30 turn to be 27 elements. Okay, now let's go for the next part of our chapter, which talk about the economic use of transition elements. Economic use of transition elements. In the economic use of transition element, we will talk about each element, why we use it or where we use it in the economic, and why we use this element in this situation. Starting by scandium. Scandium is the first element of the transition element. Scandium have 2 main uses. The first use, MiG fighter aircraft. It's a kind of airplane used in military uses. طيران حربي, MiG fighter. So the MiG fighter is supposed to be light because it's airplane, supposed to be hard because it's fighter. Because of that, it have to be from a certain alloy mixed metal, certain alloy that is very hard and very light. This alloy consists of aluminum, of course. Most of airplane made of aluminum. But we add a small amount of scandium because scandium added to aluminum make it hard and light. So the first use of scandium in making the MiG fighter, which made of aluminum with a small part of scandium. This make it hard and light. The second use of scandium, it is added to the mercury vapor lamp, which give a light close or artificial sunlight. This used in the photography in television movie when they are doing photography at night and they want to make the photo look like at day or sunlight. So they use a mercury vapor lamp which contains scandium. It gives a very strong light as sunlight. So the 2 uses of scandium again, a MiG fighter because it added to aluminum, gave it hardness and lightness. Number 2, in the mercury vapor lamp, we add some scandium to give the light very strong as sunlight, even in night. Now let's go for the second element, which is titanium. Titanium is very hard than steel and less density and very light than steel. It has 3 uses, and the 3 uses are very important in our life. The first use, because it's very strong and light, can be used also in airplane. And as we see here, aircraft and spacecraft, they are very strong. So we can add the titanium to aluminum to make alloy used in aircraft and spacecraft. Why? Because it maintains the solidity in high temperature. Of course, these kind of airplane, like aircraft and spacecraft, travel toward the sun, which is very hot, and travel with high speed, which make it very hot. So the metal could be melt. Because of that, they made some titanium mixed with aluminum, which can stand this heat without losing its hardness. So we added to aluminum to make it stand the heat or maintain the solidity high temperature. Okay. Number 2, dental implant. When you go to the dentist, and you have a teeth which contain holes or cavity or something, he adds implant. Implant here must be from titanium. Also artificial joints like knee and elbow. Artificial joints must be made from titanium. So titanium have two use in medical: dental implant and artificial joint. Dental implant and artificial joints. Why? Because of two reasons. The body doesn't reject it. Body doesn't reject it. As we know, reject هنا يعني يرفض، الجسم يرفضه. Most like kidney or heart or something، عملية الزرع. When we put something like this in the human body, the body can reject it. We give it medicine to not reject the organ. In the case of dental implant and artificial joint that made of titanium, the body doesn't reject it. We don't need medicine to stop this process. Also, titanium doesn't make poison things in the body. So these are two reasons why we use titanium in the dental implant and artificial joints, because the body doesn't reject it and it doesn't cause poison. The third and the last use of titanium, which is the titanium dioxide. Titanium dioxide used in the some creams that we use in the sun, which is called sunscreen, and it protects the body against the ultraviolet. When you go to swim, you use a sunscreen cream covering your body to not have burning by the sun, and this sunscreen consists of titanium dioxide. It's a nanoparticle that brings the body from the ultraviolet, and this helps the body not to be burned under the sunlight. Okay, now let's stop on this now today. Next time we will start with vanadium, and thank you for your time, and I hope you enjoy the chemistry, and goodbye.